Okay, so question A is asking for Fgx, so the gravitational force, Fgx. And so, Fg is equal to mg, right? But we need to find Fgx, we need to find the x component of the force of gravity. And so to do that, the C over here, that Fgx is the side opposite to the angle. And if we remember from trigonometry, that means we have to do sine. So sine 30. And then once we solve that, we should get 117.6. And remember, don't forget two significant digits. So it is 120 newtons down the ramp. Okay, time for question B. So question B is asking for constant velocity. So if it's constant velocity, that basically means that net force is equal to 0, which means that the force that the worker has to apply must be equal to the force that is down the ramp. So if we want it to move at constant velocity, the worker must also apply 120 newtons, but this time up the ramp. Now question C. So in question C over here, we get a displacement of 23 meters, and it's asking us to find the work. So we know the formula for work is F, the force, into the displacement. And all we have to do here is we'll do 117.6 times the displacement 23, and that is going to give us 2704.8 joules. And because, again, two significant digits, we'll write it as 2.7 times 10 to the power of 3 joules. Okay, now it's time for part D. So in part D, we have the coefficient, which is 0.25. And we already know the worker is applying a force of 2.7 times 10 to the power of 3 joules. Now the friction, now we need to figure out the work that friction does in this question. So again, we know the formula for work, and this time the force of friction into the displacement. So the force of friction can be rewritten as the coefficient into the normal force times change in d. And for this question, delta d, or the displacement, is 16 meters, so that's what we're going to plug in. And also it's important to remember that Fm is equal to Fgy, as we can see here. So as we can see, Fm is equal to Fgy because these two lines intersect at this point, and they are right next to each other. So to solve this, because again, this angle is adjacent to Fgy, we're going to have to use cos this time. So 0.25 into cos 30 into mg into our displacement, which is 16. Finally, to find the work, just plug it into your calculator, and you should get 0.75 joules. However, again, we're going to write that in two significant digits. So it's going to be minus, because remember, this is friction, so it's opposite to the motion, minus 8.1 times 10 to the power of 2 joules. And then the final question is asking us, the final part of that question, of part D, is asking to find the total work in the system. So the total work is simply equal to, we'll call this work 1, and we'll call this one work 2, simply equal to work 1 plus work 2, which is 2.7 times 10 to the power of 3 minus 8.1 times 10 to the power of 2. And what you should get if you do that, let's see, minus 8.1 times 10 to the power of 2, you should get about 1.8 times 10 to the power of 2 joules. So that is the total work in the system.